Time series are how you can model changes to a variable over time. This is when you're collecting data on a consistent manner at a consistent interval of time. The two main assumptions of time series models are stationarity and constant variance. If you don't meet these criteria, your time series modeling will simply be a lot of hand waving and guesswork. However, most of the time these are met. And if not, there are things that you can do to fix them. Stationarity says that your mean has to be constant with respect to time, and that your variance has to be constant. If the mean is not constant, you can apply differencing to fix it. This is when you take the series and then subtract off prior values of the series. And then if your variance isn't constant, you can apply a log transform. For instance, financial amounts are typically right skewed. In other words, once you get to like $1,000 or $1 million, it's much more likely that going from 1 million to 2 million is a smaller jump than going from 1 to 10. So there's a multiplicative difference when it comes to financial amounts. And so when you take the log of that, the log of 1 million and the log of 2 million is comparatively smaller than 1 million versus 2 million. So the types of models that you use can be remembered using the ARIMA acronym. This stands for Autoregressive Moving Average Integrated Model. The autoregressive means that the series is being regressed on itself. It's looking at past values and then fitting coefficients times older values to get to the current value. So you might, a simple autoregressive model like an AR2 model would take the past two values and then multiply them times the coefficient. And then moving average means that the series is distributed according to an average, and that average can change. Is distributed according to an average. So a moving average 1 model would simply say that or an MA3 model would simply take the average of the last 3 values and then say that the series is distributed according to, let's say, a normal distribution, and so there's a certain probability that the series will be above or below that average. And then there's, of course, the I for ARIMA. This stands for integrated, which I talked about is referring to differencing. So if your series is not stationary, then you can apply differencing to make it stationary. There's also a seasonal component. So you might hear of SARIMA. This is the this is the patterns that occur because of fluctuations over seasons. For instance, in the winter months when it's really cold, it will be unlikely that customers will want to adopt a dog and bring it in. Whereas in the summer months, in the spring, when people can go outside and go to the park, having a new pet dog is much more appealing. So you'll see a spike in your customers during April, May, and June, and a decrease in January, December. Another very important topic is, So the way that you fit time series is you look at the autocorrelation plots, which will tell you if an AR model is appropriate. You can also